Okay, the last part of this chapter, we're going to take the rational, right? And so far they've been just expressions, right? There's been no equal sign. Now, what do we got? Equal sign. So we can now actually solve for the letters. In this case, we're going to solve for Z, right? Yeah, I know. It was over on the printer. We still treat it the same way, guys. What do you think we do here? What's the first step? Take a wild guess. Well, we can find that, but to do that, like, we got to find our LCDs. But to do that, what do we got to do with some of the denominators there? And even the numerators? No, well, before simplification, you got to factor them, right? You got to break it down so we can see what we got, so what we're working with here. Okay? So let's do that first. Okay. Can we do anything with the 2? No. 2 stays by itself. Is that correct? But look at the left side, or look at the bottom on the left one there. What do you see? Difference of square. Are you guys starting to see those now finally? So Z minus 2 and Z plus 2. That's awesome. Okay, plus 10. That doesn't change. What else do we got? What about the bottom of this one? Take out a 6. You can take out a GCF in this case, right? So 6, and we end up with a Z plus 2. And equals 1 minus Z minus 2. All of a sudden, this makes this question a heck of a lot easier because you might notice something. What's our LCD? No, it has to go into both of them. Z minus 2, Z
Teacher,
plus 2.
I have a list of students that need to come to a career development meeting.
Okay.
Isaiah Alvarez,
What?
Juan Castano Galvez, Brian Chinico, Corin Cook, Janica Farino, Diana Garcia, TJ Graham,
Oh yeah,
Amy
and 6.
Johnson,
Oops.
Heidi Lezama,
And the 16.
Desiree Markley Huberdeau,
Check
Jordan
this.
Moffat, Joel Culver, Kelly Randall, Dalen Richards, Chris Roulette, Walker Rowan, Stephen Siebert, Michaela Slesiak, Victor St. Pierre Lavalette, Austin Tame, Shannon Heron, Randy Wagner, Taylor Wakely, Martin Walker, Shelby Volkowski, Ashley Warren, Tyler Watson, Eric Wolf, Dylan Woodland, Tiffany Unworth, Cheng Cheng,
All right.
Matthew Yannicki.
So,
Career Center right now, third slot, Career Development Term 2. Thank you.
so LCD, Z minus 2, Z plus 2, and 6. Okay. Now here's an interesting thing. Because of the equal sign, we can actually treat this a little bit differently. Basically, what we want to do is, would this question be a heck of a lot easier if we got rid of the denominators? Do you remember these questions back when we used to do them with fractions? Yeah, basic fractions. So if I gave you, for instance, if I gave you 1/2 x equals 6, what can I times both things by to get rid of the denominator? 2. Remember that? They're gone, so you end up with x equals 12. Remember this stuff? This is grade 9, by the way.
The time, bottom. We have to make the denominator the same though.
But you're trying to get rid of it in this case. But we use the denominators to help us figure out what the LCD is in this case. When we were doing simplification, we found common denominators because we were either adding or subtracting, right? Or multiplying or dividing, and we cancel stuff out. Look at 1/2 x equals 6. I times everything by 2. Does that get rid of the fraction? Okay, think about this for a minute. Look at just the first part here. Look at the first one, the 2 over Z minus 2, Z plus 2. What could I multiply this by to get rid of the denominator? Yeah, couldn't I multiply this by Z minus 2, Z plus 2? Wouldn't I get rid of the denominator? It would only get rid of the denominator on the first one. If we did that same thing here, it would only get rid of the Z plus 2. We'd still be stuck with a 6 and a Z minus 2. What about the last one, if we multiplied it by that? It would get rid of the Z minus 2, but we'd still be stuck with a Z plus 2 and a 6.
So what if you made them all the same?
So in that case, could we multiply by the LCD? Could we do that? Now, here's the interesting thing about it. In math, if you multiply one term by something, what do you got to do to every single other term? Same thing. You have to multiply by the same thing, right? You can take any fraction, any equation, and make it equivalent just by multiplying it by a different number or dividing it by a different number.
What if you make all the denominators the same?
But that doesn't get rid of the denominators. What we're
Then you can times small that.
Okay. So hang on. So this is where questions like this actually take up a ton of room on your page. You will need the whole next line to write this, and I actually can't even fit it on the board. I have to do it on 2 lines on the board because it's so large. So basically what I want to do is I want to take each of these 3 rationals, right, the first, second, and third, and I want to multiply each of them by the LCD.
So why multiply with it?
You'll see in a sec. Okay. Well, no, because it's easier if you do it because then you can show cancellation. Okay, now, normally when we do this, like when I did this 1/2 x, where did I put my 2? Top left or top right? Top left. Why do I put it on the top left and not the top right? So it doesn't look like an exponent. Keep the same habit. Okay, so here's my first one here. So my first one is 2 over top of, this is my first term, z minus 2, z plus 2. Is that right? That's my first term. What am I going to multiply this thing by? What's the LCD? The whole thing, right? I want to take the whole thing. So I want to take this. I'll do it on an angle a bit so you can see it. I want to multiply it by z minus 2, z plus 2, and 6. Is that correct? Okay. What's the second term? 10 over top of 6 times z plus 2. Now, here's the deal. If I multiply the first term by this, what do I have to do to the second term? Same thing. So I'm just going to write it out again. You'll find there's lots of writing involved with doing these questions, but all of a sudden they get a heck of a lot easier to do. Okay? Now you can see I don't have enough room on the board, so what do I make this equal to? What was it again? It was 1 over, I need a little bit more room here, hang on. Equals 1 over z minus 2, and what do I multiply this term by? That whole same thing again. Z minus 2, Z plus 2, and 6. All right. Just take a sec and look at what we did there. I want to make sure this is clear. So I took the original rationals. I factored it so I could find the LCD. It's the same thing you do when you deal with fractions and equations over there, right? You have you look at all your denominators, you find your LCD, right? Then I take each piece of the rational, and I multiply it by the LCD. You got that so far? Now watch. Watch what happens. It's actually quite nice, because it makes it a lot easier all of a sudden. Can you cancel stuff? Because it's multiplication, what can we cancel on this first one? The z minus 2 and the z plus 2. Can we cancel those? Awesome. Okay, hang on. I'll scroll. We'll do this one step at a time. So what do you end up with? What's 6 times 2? 12. Okay, nice. So we end up with a 12 plus. Okay, let's do the next one. What can we cancel out of this? Z plus 2, Z plus 2, and the 6s? Okay, what are we left with on the top? So 10 times Z minus 2. Are we going to have to do a distributive property there in a sec? No, let's write it down first before we actually do the jumping. Okay, so we're going to end up with 10 times Z minus 2. Is that right? That's correct? Did I do that right? Yeah. Beautiful. Well, first off, it's starting to look a heck of a lot easier, isn't it? All of a sudden. Okay. What about this last one? What can we cancel? Z minus 2, Z minus 2. So what are we left with? 6 times Z plus 2 equals 6 times Z plus 2. So what did we eliminate completely? Where did I lose you? Well, did you have that line or no? Do you have everything multiplied by the LCD? Do you have this multiplied by the LCD and this multiplied by the LCD? Do you have that?
I did like the cross, I crossed it.
Okay, so what are you left with? What's 6 times 2? Okay, 12. Because the denominators are gone, right? Because z over 2 and, z minus 2 and z minus 2 is just 1. They cancel out, right? It's just 1. We don't need to write it in. We'll do, let's forget the next one. I think some of you will actually find this much easier than the simplification. Because it's actually, what you're trying to do is take something really complex and make it really, really simple. Okay, what do you got here now? Tell me what to do next. We're going to do this?
0.
Yeah. So 12 plus 10z minus 20 equals 6z plus 12. Okay. Well, it's not going to be a trinomial because do you see a square anywhere? No. So I put the z's on one side and the numbers on the other. Or the constants. Okay, bring the 6z over. 10z minus 6z is 4z. 12 minus 20 is, 12 minus 20 is negative 8. Throw it over to the other side, it becomes positive 8. 12 plus 8 is 20. Oh, wow. Divide both sides by 4. Z equals 5. Yeah, it's actually not that bad. It looks complicated, but it's really not that bad.
First, you really have to do this by the LCD.
That is exactly right. That is probably the hardest part of that equation, is finding the LCD. Because if you get your LCD wrong, guess what? Everything else is wrong. You can't get it right. It's impossible.
That wasn't a lot of
Hang on. No, but the next one's a little bit more work. Yes, go.
They saw math.
Okay. Now, something you also have to realize is something we've been checking before is we missed one thing. You have to do the NPVs because guess what? Sometimes your final answer is going to be on NPV. So then there might not be a solution. Okay? So let's go back here and just look at the NPVs. So you go back up to the beginning. You look at, like the first line, right, the actual question doesn't help us because we haven't broken it down into its binomials here. But if you look at it, what can Z not be? Plus or minus 2. So our NPVs in this case, right, NPVs, Z cannot be plus or minus 2. Now, our answer is 5, so is it okay? Could you actually test that answer if you wanted to? Yeah, you go back to the original equation. Well, you will on the test, right? You will check that. Okay, next one.
Is there maybe like a time where more than like one is like not just K, like it's in letters?
No, it'll always be with just one letter. Like the next question. Like look at the next one here. Yeah. Okay. Well, this is kind of a dead giveaway what we're doing here. Solve a rational expression with a... Right, this is what I was talking about, right? We're going to find one that doesn't work. Okay, so you look at that and you freak out, right?
Yeah.
You have a panic attack, you go screaming from the room, like I do every day when I see math. No, but what do you got to do? Look at this, guys. You got to approach it the same way. You got to kind of take a step back. You got to look at the question. What do you got to find? You got to find the LCD. Right, bang. So you got to find. Now you can't find it by looking at it because the problem with this sucker is it may not be factored, right? So should you factor it? As much as you can, right? And really we don't care about the tops, but could you factor the tops if you wanted to? Sure, why not? I think I did it in this case, did I? No, I didn't even do it in this case. Okay, so K plus 2, what about that? Does it need to be factored? K minus 2. What's the only one that needs to be factored? And what is that? Difference of squares. Okay, so let's write it out one more time here. 4 4k minus 1 over k plus 2. And guys, here, now watch. I'm going to start saving myself a little bit of space when I do this question. I'm going to try to take this question and space it out a bit on the page. That way, can I start writing in my LCDs above it so I can cancel? Yeah. Minus k plus 1 over top of k minus 2 equals k squared minus 4k. What? You can if you want, but you don't really need to. The bottom is really the only one we're interested in. We can factor them in. You'll understand why I didn't factor the top and second. Okay, what's the bottom? K plus 2, k minus 2. Is that correct?
Yeah.
That's why in this case. So you look at what we got here. We got a k plus 2, a k minus 2, a k plus 2, and a k minus 2. Now here's a question for you. Could this be a possible LCD? Or could this be a possible CD, common denominator? Could I put all 4 of those together?
Yeah.
Would that work?
Yeah.
Is it the lowest?
No.
No, in this case it's not, right? You have 2k plus 2s, you only need to use one of them. You have 2k minus 2s, you only need to use one of them. Okay, so I'm going to write up here, and I always write on my page, okay, LCD. LCD in this case is k plus 2, k minus 2. Is that correct? Heck, you know, while we're doing this and we have some room on the page, let's just throw down the NPVs. Live dangerously.
It's so dangerous.
I know. Math is a dangerous sport. It's not quite a sport. Okay, what are our NPVs, guys? Look at the bottom. Okay, so k cannot be plus or minus 2. Okay. So, this is what we got so far. We looked at our question. We factored it. We figured out the LCD. We figured out our NPVs. So now we got to take each of the terms, each of the rational pieces, and multiply it by what?
LCD.
The LCD. So I'm going to put it now. Why am I putting it on the left and not the right? So it doesn't look like an exponent. Okay, good. So I'm going to do this. What is it? K plus 2, k minus 2. And I'm going to do it to all of them here, right? I find if I'm consistent, like if I do it all at one step, I usually don't make as many mistakes. There they are. They're all on the top left. You see how this can start to look kind of complicated, eh?
Start.
And most of the times you are asleep when you do my math, so.
I've got a nice 8-week coffee.
Should we put the markup on the board so everybody can see it? I got no issues with that. Oh yeah, it would be on the video for all of everybody to see. That'd be good. Okay, what do we do now, guys? Cancel. So k plus 2, k plus 2.
Not done you, Paul.
Okay, so the k plus 2's disappear. So if it's interesting, in this case, what are you left with? You're left with k minus 2 and a 4k minus 1, but 2 binomials. What do you think you're going to have to do with that one when you're done? You're going to have to do FOIL, right? Because you're going to have to end up with a trinomial so you can kind of collect all these. But for now, I'm just going to write the 2 of them. So k minus 2, 4k minus 1. The nice thing about that is, did we get rid of the denominator of this rational? Yeah. Oh, you're all going to end up like me. That's dirty. Poor Mr. McLaughlin when he gets here in his grade 12 math class. He always knows which students I've taught. They're all just a little bit different. All right, next one. What cancels? Which one? K minus 2 minus K minus 2. Now, careful. Careful on this one. Why do you have to be careful? Because of the negative sign. You have to be careful of that negative sign. It is where you're going to screw up on this one. Okay, so negative, what is it? K plus 1 and K plus 2. Now, you got to be careful of that. You're going to FOIL that, and then you're going to have to distribute that negative. Equals, what about these ones? Nice, that one works out really well. Equals k squared minus 4k plus 24. Well, you don't have to, because what are we going to do in this case? We're going to take the other binomials and FOIL them. We're going to end up with some k squares, and then we're going to collect like terms. So if I had factored that back part, that back trinomial, right, I'd have to FOIL it again anyway. So I'd be like going forwards and backwards, right? And if you want practice, I guess you could do it. Okay? Try the next line on your own. Try to FOIL those. And don't simplify yet. Just FOIL and run it across the board there. Or run it across your paper. See if you can get it. Find out in a sec if you did it right. Guys, stop that, please. And then there's one kind of last part with this that you might freak out when you see, because it might be a... Well, if you can't factor the final answer, you might have to go to the old standby quadratic formula. You might. Not in this case you don't, but you might get a question like that. Why not? It'd be a beautiful question. It would be like the Mona Lisa of questions. She was smiling because she was doing math. And she got the answer to this one, so that's why she has that sly smile on her face. Hang on.
I don't see it smiling or smiling.
She's laughing at you.
I'm confused.
What? Did you FOIL the first part?
Yep.
So what'd you get? Tell me what you got.
4k squared minus k minus 8k plus 2.
Minus k minus 8k plus 2. Okay, so that makes sense. That's the first part. Hang on. Okay. So guys, this is the one that's going to throw you, the negative. So what I would recommend is keep the negative out there and FOIL that whole sucker and put it in brackets. If you put that whole thing in brackets, will you remember then to distribute the negative? Yeah. Okay. K squared plus 2k plus k plus 2. Is that right? Now, you guys will get faster. That you won't normally be writing out those middle terms, will you? No, you guys figured out the FOILing, right? You can do that. Okay? Okay? I guess I should have picked a different letter than this one. K squared minus 4k plus 24. Okay. Make sure you got that line. That's, guys, you should be able to do that. That's... No. Okay, so let's do this next line. Okay, so 4k squared. What's negative k minus 8k? Plus 2. Now, careful on this one. Basically, what I'm going to do is I'm going to distribute, right? So, negative k squared. Now, what's 2k plus k? 3k, and then it becomes negative, right? So negative 3k. The positive 2 now becomes negative 2 equals k squared minus 4k plus 24. It's a lot of junk on the board, right? It's a lot of junk. You've got to really be careful. Okay, we're going to do that, right? So the next step would be to make it all equal to what? 0. What's that called when we put it in that form? Sorry? Standard form. That's standard form, right? So that's the ax squared plus bx plus c all equals 0, right? It's in plain old standard form. Normally with squares, do you put it in that form? Yeah, the last example we did didn't have a square in it, so we didn't do that. We just solved it like regular algebra, right? Okay, so we're going to move it all now. We're going to move it all to the left side or the right side? Left side. Can we combine some of it before we even move the right-hand side? Yeah, you can do the CLT on the left side because there's, 6 terms? We can collect some of these. Let's do that. Let's make our life easier. What's 4k squared minus k squared? 3k squared. Negative 9k minus 3k. Negative 12k. And positive 2 minus 2 cancels out. Okay, so we're left with still k squared minus 4k plus 24. Right, each step we do this simplifies it a little more. And that's the whole key to anything to do with this, right, or algebra or solving. If you take something that's really complex and you just work through the steps until you get down to a final single answer. Yeah, well, you just follow it. I mean, and did you learn in grade 9, did your teacher show you, I know I show my students, sometimes, you know, I circle the stuff that's the same. Did somebody ever teach you that? Or use boxes or use triangles? Yeah, you got to make sure you circle the negative because that's really important, right? So that works on that one. So that, you know, I could do that. And if I wanted to switch colors, right, I could do the -9 and the -3. Nice enough. You can do that as you go along. Some people really like doing that because it keeps them organized. Some people just put lines through stuff as they're going, right? Doesn't matter to me how you do it, as long as you keep yourself organized. Right. So let's move this all and make it to 0. Okay, so positive, guys, positive k squared, we move it to the other side, becomes negative. So 3k squared minus k squared is 2k squared. Negative 4k, we move it over to the other side, becomes positive 4k. So negative 12k plus 4k is negative 8k. And the 24, it's positive, comes to the other side, becomes negative 24. And this is all equal to 0. Okay. Now, this comes back to the stuff we did 2 months ago, month and a half ago. It's a trinomial, right? So you look, hang on, you look for a couple key things. You always look for what first? Always. GCF. You always look for GCF. Secondly, you take your trinomial and you always try to factor it into 2 binomials, if it works. If none of that works, then you do quadratic formula. Okay, what do you see? I can see a 2 can be taken out. You're correct. Okay, so let's take out a 2. And you should see right away, you'll start to see them really fast. If you see a 12, right, you start thinking of all the factors of 12. 1 and 12, 2 and 6, 3 and 4. Can any of those be subtracted? Can any of those be subtracted to give you a 4? Well, yeah, okay. So let's do that. Yeah, I know. The negative in front of the 12 means the signs are different. The 2 factors, we want it to be negative 4, so it's going to be negative 6 and positive 2. Is that correct? In front? You could divide it right out. Is it going to make any difference to the answer? What's 2 times... Because we're trying to figure out which one of those equals 0, right? 2 times 0, does it still equal 0? It doesn't make any difference. So does that 2 have any difference? No, you can take it out if you want to. If you want to divide both sides by 2, go right ahead. Won't make any difference. Okay, now to solve this, we make each side equal to 0. Is that correct? K minus 6 equals 0. K plus 2 equals 0. So in this case, K equals 6. K equals negative 2. We're done, right? Yep. We go home and have a nice bottle of ginger ale. Which one? Which one of those is an NPV? The 2. No, the negative 2. Okay, now, guys, look. I'll scroll this back down a sec. Look at the top here. We found out a long time ago that our NPV, K, cannot equal either positive or negative 2. So this thing right here, this thing at the bottom here, that thing at the bottom there where it says K equals negative 2, what is that? This is an extraneous root. Extraneous root. Now, we needed it. So we could solve the question. Right? Because it was a trinomial, we needed it to be one of our numbers for our binomials. But it's not one of the answers. So in this case, how many answers are there? 1. It is 6. And could you test that? You could take it, you go back to the original equation and plug it in. No, because we did we found out it's an extraneous root. We don't need it.
Alright.
Okay, guys, just a quick review of what we did. You take the rational, right? The difference on this one, these ones are, they have an equal sign in them now, right? You're going to start solving for the letters. To do that, you're basically trying to get rid of the denominator. You're trying to wipe it out. Now, here's the deal. If you're doing the question and you get to that step and you haven't gotten rid of the denominator, have you made a mistake?
Big time.
Big time. Okay. So then you look at the question. And you go to the question, you realize, okay, there it is there. You got to do some factoring in there, right? So, because you need to factor it so you can find the LCD, right? So you figure out the LCD. Stop. Take another 30 seconds, go back, make sure you have the correct LCD. Because if you have the wrong LCD, guess what? Everything else is wrong. And you'll know right away, as soon as you get to the next line, if you have a denominator and you have the wrong LCD, right, something's wrong there. You got,
Nothing cancels.
yeah, okay, so then you'll know. But some students just keep continuing to barrel along full steam, right? And then you stop and think about, well, you're there, you might as well figure out the what? Oh, what the heck, you might as well figure out the MPVs. Okay, so then you times each piece by the LCD, do it on the top left, cancel things out, and you should end up, if you've done it correctly, you should end up at this stage right here, what should you end up with if you're done it at the right stage? Where the little star is here, what do you end up with? You end up with one solid line with no denominators? That make sense?
What's the difference between this question and this question?
The one previous page?
Yeah.
Nothing.
Why
Oh, that has an extraneous root.
You did a different way.
No, I didn't. This one didn't have, the first one didn't have squares in it.
Yeah.
So we just solved it algebraic way. This one has a square in it. And we found out we had an extraneous root. Okay? So then you go along, right? You solve for it, and you might have to do it a bunch of different ways. GCF, factor the trinomial, if not, quadratic formula. And I think some of the questions in the book, you have to use this final step. You have to use a quadratic formula.
Quadratic formula.
Negative b plus or minus the square root of b squared minus 4ac all over 2a. You should have it memorized.
Who wants the video?
No, we're not watching the video. Okay. That's it. They're done.